All right, welcome back, everyone. So thank you to all the presentations, the presenters who presented before this. It was great to hear from the community on all the work that they're doing with ONNX, around ONNX, helping the community grow and evolve there. So now we're moving into a couple of presentations from the SIGs and working groups. So as we mentioned at the very beginning, kind of the heart of the technical work of ONNX happens in the SIGs and the working groups. This is where technical decisions are made and work is actually implemented. So each of the SIGs and working groups is going to present, and we're going to kick it off with the architecture and infrastructure SIG. So Lukun is one of the SIG co-leads for that, and he's going to come up here and give us the update.
Thank you, Prashant. Hi, good morning. My name is Li Chun Fu. I'm from Microsoft. And I'm here. I'd like to give a update on the architecture and the infrastructure SIG, and also present the roadmap for future development. No. Okay. Okay. Yeah. Okay. Great. Thanks. Sorry for that. First, I like to. There has been 2 releases since we met a year ago, and I like to thank Fritz Maslow Wisuki from Intel and Yuan Yao from NVIDIA for their contributions as release managers for versions 1.13 and 1.14. And with the latest 1.14 release, the ONNX IR version has been bumped up to version 9, and introducing 8-bit float specification and providing more support for local functions. And thanks to the contributions from our community, we have added many more new features, exciting new features, including a reference implementation for ONNX operators, and serialization with text portal format in addition to portal buffer. And now function ops can have multiple bodies, each corresponding to a specific offset version. This enables EDA version conversion, which helps from inline function inline utilities, which is also new. And documentation page has been added to ONNX homepage, and that enables users to view, for example, specification changes across different operator offset. Yeah, as an example of this latest documentation, here I have a site showing a comparison between version 13 and version 18 of operator split. Instead of have to reading both specifications and do a mental comparison, this page clearly shows that in offset 18, a number of output was added as a attribute to the operator. I always use this page, this type of diff page when working on computing kernels for updated operators. And there's another feature I just mentioned, with the ONNX reference implementation added. We can now execute a ONNX model without runtime. And this is very helpful. here, this is a export function from Project MONAI, and when a PyTorch model is exported from PyTorch to ONNX, ONNX reference evaluator can be used to validate the model. So there's now, once you have model converted, you will be sure, the model is correct. And this is, even you don't have ORT available, which is, great. And the next, okay, sorry. Okay, and next, there's another new feature I mentioned, which is to do serialization with text portal. And this is also very useful. Here I have model exported from a sequence of pre-processing transforms. And you can see here, there's they are duplicated cast node, which is not needed really. And I can simply writing out this model in text portal and using a text editor to delete those cast node and do some text find and replacement. The model is fixed and ready for use. And this is, those are just one of a few new features added to ONNX, and I encourage you to explore and take full advantage of it. And in the future, we will focus on the following areas. First, we want to maintain a highly, high quality, stable CI infrastructure, and in the meantime, we want to transform more operators into function op, so that we have, small surface, a compact surface. And the last, which is also very important, we like to work with operator pre-post processing and the converter SIGs to support real-world models in production. And as for this last, real-world model support, I like to give a specific example of the progress we have been doing so far. And here I'd like to introduce another project, Project MONAI, which is funded by NVIDIA and King's College of London. And this project hosts many PyTorch models in medical imaging domain, with 20+ state-of-art models published in its model group. And recently, ONNX export utility was added to the repo. It uses ORT and ONNX reference implementation for model validation. While integrating ONNX with MONAI, we found that being able to run a ONNX model on a core neural net in ONNX is not sufficient. The medical imaging workflow, involve heavily of substantial post and pre-post processings. It is necessary to put end-to-end MONAI workflow in ONNX in order to apply its life-saving innovations anywhere on any hardware. And here I like to give this slide shows a common medical imaging workflow. And medical images are usually acquired with various acquisition protocols, causing or resulting in difference in orientations, positions, and image pixel intensity. And before those images can be used for training and inference, they have to be transferred from patient acquisition space to a normal standard space, and with image pixel intensity normalized. And this represents the minimal pre-processing needed. And also, neural net are trained with fixed dimensions. Well, input medical imaging volumes change inside or differ inside. And MONI uses an inferrer class to encapsulate handling of this aspect. Here, a sliding window inferrer is used to process the input volumes in patches. Each individual patches is passed to a core neural net, and the output of this core neural net is aggregated to produce an output for post-processing. And this post-processing step involves activation and transform the output back to the patient space and more. Here on this slide, I like to stress that at its current stage, ONNX model in MONI is only used to process individual patches within inferrer. The rest of the whole workflow is done in a Python environment with PyTorch. And here we are working with ONNX pre and post-processing group to find ways to convert a composition of image processing transforms from Python and PyTorch code into ONNX. And operators will be added or updated for this purpose. And thanks for the expressive power of current ONNX offset, where all the new operators needed a function ops. We are also working, we have also proposed a new operator called the sliding window inferrer to the operator SIG. And this operator is also a function op. And but implementation of this function op is not simple. So okay, yeah. So for this one, we used a ONNX script just discussed by or presented by Rama, and you can see we can use just a Python function to define the function body, which is also great. And at the end, we will have we will be able to put a complete medical imaging workflow in MONI to ONNX and run as promised. And this work is in collaboration between our different SIGs in the ONNX community, and hopefully at the end we will be able to just grab model from MONI model 2 and have it run in anywhere. And yeah, that's the end of my presentation. And Alex, thanks for giving me the chance to talk. And please get involved, in the ways listed here. Thank you.
Any questions for Lishan?
So you mentioned about the verification of the model once it's exported to ONNX using the new reference implementation. Do you have any details on what happens underneath? Is it comparing the outputs of the two models? Or?
Yeah, because the question is for the reference implementation and the details of how it is done, right? And yeah, the reference implementation was added for this, currently available in ONNX. And basically, we have for each operators, we have a kind of kernel to run, and if you have input, it will do the computation the same way as other runtime. But most of the computation is in NumPy. And yeah, basically, and once if you have a model, import PyTorch, and PyTorch already have you can execute it to get the output. And when you run the ONNX model with reference implementation, you will get also the output. It's just a matter of compare those two outputs to make sure the model is correct. Yeah, thank you.
All right, thank you so much, Lishan. Yeah. The architecture infrastructure SIG runs the releases, so we're always very grateful for that SIG and everyone who helps with that.